welcome to this video. And in this video I wanted to have a look at something a little bit different, and it was looking at the impact of Earth's varying gravity on different sorts of sports. So like the Olympics, and in the Olympics there's a lot of events where you're throwing things, lifting things, and if you have a different gravity at different locations, surely that's going to impact the sports that you're participating in. And because recently, or fairly recently, we have quite detailed maps now of that varying gravity on the planet. So we can kind of have a look at that and how it varies. So first, we're going to have a look at gravity in general. So uppercase G is your gravitational constant. That is a constant, and it's kind of the same throughout the universe. And then you have lowercase g, which is the acceleration due to gravity, or it could be like the surface gravity on the planet. And we're interested in that bottom one because this one is not a constant, and that is dependent kind of on where you are, really, on whatever object you're interested in. So that lowercase g is different for different planets, but it can also be different where on that planet you are. So for Earth, we can calculate the surface gravity because it relates to the radius of the Earth and the mass of the Earth, and then your gravitational constant. So you can see that if you change the mass of the Earth, you change the actual radius of it, you're going to get a different G. And this is the acceleration due to gravity on the surface. Now we know what that is because if we drop something, you can measure the acceleration. And in fact, it can be fairly easily measured. It is an acceleration, so you're measuring that, and it has an average value of about 9.80665 meters per second, and that's the acceleration due to gravity. And I mentioned there that it's an average, so that's averaged across the whole planet, but it does vary from location to location as well by small amounts. But the first thing to note is the Earth isn't a perfect sphere, so the radius of the Earth isn't constant, it does change at all locations. So the most obvious one is actually that the equator has a larger radius than the pole to pole distance because it's rotating, and the equator is spinning the fastest, so it's slightly squashed, so the radius is different there, which obviously changes things. But it's a little bit more localized than that. So if you look at specific local places on the planet, you can have much higher gravity and much lower gravity. And it's not just about the overall shape of the planet, but like the small changes on it. And actually here you've got the Himalayas noted, which are red, which means that they've got higher gravity. Now, you've got a video showing that full map here. And you can see you've got red regions, which are higher gravity, and you've got blue regions, which is lower gravity. And the thing that should stand out immediately is that the red regions are where the mountain ranges are. So where you've got mountains, you've got more mass. More mass means that the gravitational attraction at that location is greater than the lower lying regions. And that is mostly where it comes from. It's the distribution of mass where it comes from. So just to note one example here, you can see you've got blue regions, red regions, bits in between. But if you take like the United Kingdom, you've got a higher gravity there compared to kind of the east part of Canada. So you've got lower gravity in Canada, higher in the UK. You can see there's lots of locations like that where you've got higher regions and lower regions. And you've got the amount, it varies there. And it's kind of from plus or minus 60 milligal, which is a unit of acceleration. So in Olympic sports, and actually this is true for a lot of sports, but I thought I would just kind of note the Olympics as an example because you have quite a good collection of particular sports where you're throwing things or you're fighting against gravity. So you've got javelin, you've got shot put, discus, hammer, Olympic weightlifting, and all of these you're fighting against gravity, which is trying to pull you down. Now, if you've got lower gravity and you throw something, you can probably throw it a bit further. So if you go onto the moon and you were to throw something, I guarantee you can probably throw it a bit further. There's a few other reasons why, but gravity does affect things like that. And obviously, weightlifting, if there's less force pulling you down, then you'll be able to pick up larger objects. So you're always fighting against gravity. But if that's different in different locations, what does it actually mean then? Well, let's take two examples here. So you've got Montreal 1976 and London 2012. If the mass doesn't change, let's say the shot put, it's the same object that's used in both, has a particular mass, but the effect, the local effect from gravity, is slightly different in both those locations. And at the Olympics, you have things like world records, Olympic records, so whether you can beat an existing record or not. Now, if you're in a lower gravity region, maybe you can throw it further. There's a slight advantage there compared to where there's a higher gravity region. Now, the difference between the two is from the plot anyway, approximately 40 to 50 milligauss between Montreal and London, where the two Olympics were. And I've only just pulled those out as an example. There's going to be more other examples which may have bigger differences actually. But to put that into perspective, is, well, 1 milligauss is the equivalent of 0.001 centimeters per second in acceleration. Or in terms of g, so the total value of g, which is about 9.8 meters per second, it's about 0.0001% of that. And there's a difference of what, about 40 to 50? So let's say 50. That's a difference of 0.05 centimeters per second, or 0.005% of the total value of g. So they're incredibly small numbers. What does it actually mean? Well, it is easier to lift things when the gravity is lower, but it's unlikely to be noticeable. There's probably going to be bigger effects there that are going to affect the performance on the day. So specific things relating to the athlete, if they've not had great sleep, they're probably going to have a bigger difference there. The actual local weather conditions, a few other things are going to have a bigger effect on what the gravity would. But the gravity is going to have some effect, but it isn't necessarily going to have anything that's likely to be measurable in these records. But it's something maybe worth thinking about. It is very, very small, but it is easier to throw things when the gravity is a little bit less. So thank you for watching, and if you enjoy, then check out some of the other videos.